Hi, I'm Tash, welcome to iScience. Today, approximately 1 billion people are suffering from chronic hunger, yet populations are still increasing. This combined with factors such as climate change mean food security is one of today's most pressing issues. Professor Sir Gordon Conway has dedicated much of his career to researching issues of sustainable agriculture. He's worked across the globe, from Europe to Africa to Malaysia. He was also one of the pioneers of a technique called integrated pest management. This involves reducing pesticides and insecticide use and increasing biological control agents. Today he's been giving a talk at Imperial College discussing his new book and how we may be able to feed these 1 billion people.
Professor Sir Gordon Conway leads the Agriculture for Impact programme, which advocates for more European government support for agricultural development in sub-Saharan Africa. Professor Conway trained in the UK as an agricultural ecologist in the heyday of the Green Revolution. During his talk, he called for a new paradigm for feeding the world, which he calls a doubly green revolution. Today, food security faces three interconnected challenges, including the reoccurrence of food price spikes, the prevalence of chronic hunger, and the fact that we have to increase food production by 70 to 100% by 2050 in order to sustain the world's growing population. The doubly green revolution is largely based upon the process of sustainable intensification, which essentially means more with less. In order to realise this, we need to focus on technological innovation, markets, people, and political leadership. We need higher yields of crops, using less water, fertilisers, pesticides, and reduce emission of greenhouse gases, while at the same time maintaining the flow of environmental services, including pollination and nutrient cycling.
These are the food price spikes. And notice that we're into the third spike since 2007. The problem with the food price spikes is that the food prices go up in developing countries and poor people spend most of their income on food. So it really hits them. I mean, all of you in the audience may grumble because food prices are going up, price of bread's gone up, and so on. So but for poor people, it's devastating.
Ecological principles can be used to design agricultural practices so that they may be as efficient as possible. Examples include agroforestry, integrated pest management, and organic farming.
Conservation farming is another ecological approach. We all like to plough in this country, and a lot of ploughing is done in Africa too. But with ploughing, you tend to destroy the soil, and you destroy its water holding capacity. And what conservation farming does now is to cut down the maize when you harvest it, lay it flat on the ground, so it rots away into the soil. And our farmer and our husband there are producing about 7 tons of maize per hectare from this system. It's spreading quite rapidly in Africa.
Plant breeding and genetic modification are important tools in realising sustainable intensification. Plants can be made to be more nutritious in terms of micro and macronutrients. They can be bred to increase resilience to pests and disease, as well as climate change-related factors. Finally, their efficiency in photosynthesis can also be increased, as well as water and nutrient uptake from the soil. All of these examples will allow for the reduction of fertilisers, pesticides, and insecticides, which in turn will reduce negative environmental damage. One example being used is the increase in orange flesh sweet potato, which contains higher quantities of vitamin A compared to common African white variety.
This lady here, Maria Andrade, who is a Cape Verdean islander, she introduced orange flesh sweet potatoes into Mozambique and then started to breed new varieties that were suitable for Mozambique conditions, in particular new varieties that would stood drought, all by conventional breeding.
After the talk, I had a chance to ask Professor Conway a few questions regarding sustainable intensification. It seems kind of an oxymoron. On one hand, we want to increase yields from a farming system, but in the past that's led to a lot of environmental disruption. Can you explain a bit about what sustainable intensification entails?
Yes, you're right. It does sound like an oxymoron. I mean, that's where the challenge is how you can get both intensify agricultural production and sustainable agricultural production. We have to intensify because there's not very much new land available. In other words, if we're going to feed the world by 2050, we're going to have to produce more food, which means higher yields and higher production on the same amount of land. But it also has to be sustainable, and that means we have to do it in a way that is environmentally friendly. In other words, with less pesticide, less fertilizer, less water, less emissions of greenhouse gases, things like methane and nitrous oxide. So we're trying to do the two things: more yields, less inputs, and a much lower environmental footprint. That's why it's tough.
Okay, great. And a lot of the research going into this sort of agriculture is done in the EU and North America. Is there a problem at all with less research being done in countries such as Africa or Asia, or is it easy to transfer the knowledge?
No, it's not easy to transfer the knowledge because conditions are different. We need much more research. We need more research in Europe and North America as well, but we need to focus much more on sustainable intensification in Africa, in Asia, in Southeast Asia, and in Latin America. It's a big task and it needs a lot of investment.
Okay, and one of the methods being used now is breeding different crop varieties,
right.
Genetically engineering them. Is there ever a worry that if you breed a crop that's able to grow in drought or high salinity soils, that it's just adapted to those specific conditions, and then if suddenly the weather changes or anything happens that we didn't predict, then that crop fails?
Yeah, first of all, one should say that modern plant breeding isn't just about genetic engineering. There are lots of other kinds of plant breeding that are being used. In fact, most of the breeding at the moment is not genetic engineering. It's marker-aided selection or tissue culture or so on. It depends whether you breed something specifically for a particular challenge, whether it's a pest or a disease or drought, or instead try and breed it to deal with a range of pests or diseases, or to deal not just with drought conditions but with good conditions. They've done that with something called deep flooded rice. Sometimes you get floods and the rice gets covered with water. If the rice gets covered with water, it dies. They've now bred, using conventional means, a rice that will withstand deep flooding. But it'll grow well even if it's not flooded.
Okay, that's very interesting. And at the moment, the population is still rising.
Right.
Do you think with the methods of sustainable intensification that you just discussed just now in your talk, that we'll still be able to feed all the people even if it keeps rising, or do you think that now the population should really maintain?
Well, the best estimate is that the population is going to stabilise at about 10 billion people. That's another 2.5 billion from now. And if what I've been talking about really happens, if we do the research and we do the organisation and we have the political leadership, then we should be able to feed 10 billion people. But we do need to make sure it starts to stabilise very soon.
Right, and sort of related to that, with increasing populations and increasing wealth, obviously more people are eating meat. Do you think that people should consciously try to eat less or even become vegetarian?
Well, I think we should cut down on the amount of meat we're eating, because the problem is that very crudely you need 8 kilos of grain for every kilo of meat that you produce. So it would be good to reduce it. But the momentum to increase consumption of meat, particularly in emerging countries, places like China and Brazil and so on, is enormous. And I don't see those countries becoming vegetarian. I don't even see Britain becoming vegetarian in the near future.
Yeah.
I think the answer is going to be synthetic meat. In other words, you take soybean or other crops like that, and you convert them into something that looks like meat and tastes like meat.
Yeah, okay. And when you, I know you used to work in Malaysia.
Yeah.
When you were working there, how much did indigenous and traditional knowledge contribute to scientific research? Did it at all?
Oh yes, I think when I was there were all kinds of traditional ways of dealing with pests and diseases, because that's what I was working on. And it's very important to use those traditional means. But they're often not as effective as they ought to be. And that's where you have to use modern technologies to deal with a pest or a disease or something of that kind.
Okay, and now looking ahead, what do you think are the biggest challenges for the UK over the next 50 years in terms of sustainable intensification, and how does that differ to countries such as somewhere in Africa like Uganda?
Well, I think there's very big differences there. Uganda, like many African countries, has got average yields of about 1 tonne per hectare of grain like maize or millet or whatever. Whereas we here in Britain have average yields of grain crops that are 6, 7, 8 tonnes per hectare. So they've got to increase their production much faster than we have to. But we still have a big challenge of producing more of the temperate food crops that we eat in Britain. We only produce about 60% of the temperate foods that we need in Britain. So I think that into the future we're going to be producing more of that, and we have to produce it in a sustainable fashion.
Although it seems a daunting task, Professor Conway remains positive that we will be able to feed the world by 2050.